Today's video is on inspectionware packages, and it's a top-level video to give you an idea of what they are, how they work, how you can use them, and in later videos we'll get into more details. So what packages are is an encapsulation of functionality expressed by a group of nodes that can be developed, tested, and deployed in multiple workspaces. And packages there should be a clearly defined functionality. They should serve a particular function that's maybe bigger than would be expressed in a single node, but less than a full workspace or application. And another thing that's important to know starting off is that packaging is a pattern. It's not a single node, and it's implemented on different nodes such as processor, package, user-defined node, and structured file. So what you might use as a package would be, say, some data processing tools. Say you've got some spec to run on some ultrasound inspection you've done that needs to run some processing steps and make some determinations. That would be a good data processing package. You could do a part builder simulation that builds parts for a given inspection, or some type of inspection, that the parts that would go in the simulator, a focal law calculator. You know, if a hardware management tool, the case would be, say you've got a scanner that might use 2 or 3 different phased array types, you could write a tool that swapped those out and managed that exchange of hardware. And then you could write a tool that imports different data files and pre-processes in such a way that they're in a standard format for your app to use. The way the packages work is they expose properties, tasks, data in, data out, tables, and so on. They're exposed on the package. So the package consumer uses the exposed items, and the package author is free to change the functionality inside the package of how the functionality works and keep the interface the same. The gist of the packages is how they work is that they've got a bunch of internal folders, and there's a bunch of known types of folders, of given names and functionality, and some nodes have given names and given functionalities, and the package author fills those in. For example, there is a tasks folder, and all the nodes sitting on the root of that are exposed as tasks of the packages. Properties in the properties folder, exposed properties in the properties folder are exposed as properties of the package. The data comes in a given way, it goes out in a given way. Tables are exposed from the table folder. So those are the patterns. They're based on internal folders. So we'll have a look at a package that I did, and it's quite simple. So the idea here is you want to put a crop rect around the peak. So I'll run that one. This changes my data. I run it again, and the crop goes here. So this is the output of the package, this crop here of this peak, or the first peak. So we'll just have a quick look at how this works. So this is my package here, and this is the internals of it. So to give a really quick overview of how it works, this is my source data. It's plumbed into this is an aggregate data. This is a known name input data. That's a known folder. So that's where your input data always lies, where your source data always connects there. The tree here is fairly straightforward. It's a peak detect. Find the peak position, find the peak width in the two directions. Those get passed down to this crop rect node, and that runs, and then the input data and the crop rect get exposed here. That in turn gets put out to outputs of the package, and we're done. Again, this is another known folder. Anything that's in the root node that's an output here shows up there. And this is another known folder. That's your source data lands there. It gets connected to that point. Okay, so that's the data flow. It comes from here, goes to there, through these trees, and back out. Okay, so task folders. Anything on the task folder here, anything root node, is a task of the package. Okay, here we go, those two nodes. But there's also another, there are known task names that will be run in certain conditions. So on compile is run during the compile of the package. On execute is run during the execute of the package. Okay, so on compile, this is a task of the package, and it's here. Connect input data, and it connects the input data there to that known place. This exposed data takes this output and puts them there. So our data at this, the compile plumps the data, and the execute then runs the data. So it runs this tree, which finds the center and two widths of the peak, puts them into the crop rect. Step 2 runs the crop rect, and run the output data. It freshens that up, and you're done. So a couple of things to note. Not everything, you do have to do some of the plumbing yourself. It's not automatically connected, and the reason for that is just to give the package author control over when things happen, so that you're not wasting cycles or doing extra refreshes, always connecting the data. If it's in the same place, for example, you're not, it's just done when you need it. And that's just something, you know, it's a design decision sort of between having, you know, less work to do on the author, but also more efficient execution if you have control over exactly what you want to do. Okay, finally, properties. So the pattern here is known name, again, properties, and it is exposed on this object. So you can see those match. And any exposed property here, like a variables table or link properties, will show up on the output. And then if we look at my interface, I've dragged out this properties window to there, the two outputs, and my execute. So nothing is touching the inside of the package. And I'll just show you what I did. These are sort of outputs. They tell you where the position was. They're just grabbed from the center positions of the processor. Sorry, that one. And what these ones are is I put a property on my copy scripts that then increases or decreases the width that it finds to give you a bit of a border. So if I go to 2, that'll double the width and give me a bigger border around that. So that just gives you an example of how you can control the processing, but the flow goes, those are exposed on the package. That comes from a link property to there, and then you've got control over the package. So hopefully those are some basic ideas of the package. I think we'll go into more details on subsequent videos, but that sort of will help you get orientated in the big picture of what's going on with packages.